Good morning, everyone. Inform your friends to join the class. Hello. Okay, in the previous class, we just discussed about the typical chemical reactor, a simple chemical reactor result, which was used for understand the sequence. Sequence control means a precise set of operations has to be done in the sequential way to get the desired product. So we have seen a lot of examples, as I mentioned. The examples like I've shown in the video, the food processing industry will employ the sequence control. Then the how to save the time. So in parallel, we can achieve the sequences can be carried out in parallel. This is the example of having two reactor results R1 and R2. Thereby, we can save time. We can save time. So the next topic of discussion is loop control. So loop control is also called as DDC, direct digital control. So in direct digital control, the computer is in the feedback loop. The computer is in the feedback loop as shown here in this diagram. So you can see here, so this is a process or a plant or an industry which is to be controlled via computer. So you can see the box AAA written as A. They are the actuators. Actuators means they perform the specific job of actuation. Means in the precise way, they'll be trying to control some external environment. For example, if you observe our JNC buses, the shaft that is the door will close automatically if the driver presses the close button or open button. So if that button is pressed, the shaft will move and the door will close. So pressing of button by the driver is the set point, and the job carried out by the actuator is nothing but the close opening of the shaft. The opening of the shaft will or close the door. Similarly, in the backward movement will open the door. So if you just observe the JNC door bus, you will got to know about the actuator. There, the cylindrical hydraulic shaft is placed at the door point or the door entry, so which will open and close. So what I meant to say is actuator will control the external environment based upon the input received. Based upon the input received. That is one typical example of uh, feedback control system, or the computer is in feedback path. The computer will be in feedback path or feedback route. So the main advantage of having a computer is we can precisely manufacture the goods. For example, just remember your good old sticker cutting art. Sticker cutting art, it was an artistic manner. Nowadays, that has been replaced by computer cutting. So if you purchase a vehicle, we'll go to a sticker shop and we'll put names and look at the precision of cutting there. The computer ಯಾವ font ಕೊಡ್ತೀವಿ, that font will be cut with the help of a laser cutter or a normal cutter, so which will get the beautiful art. So even art can be digitized. Art can be digitized. So digital computer precision is very good. Precision is very, very good. That is why one has to go with the computer. So I can say here it is measuring the outputs. It is the measuring the outputs, whether the manufactured goods are meeting the quality specification or not. If it is not sufficiently manufactured, again there is a feedback path existing between the process outputs and the actuator. So it is, hello. There is a specific path between the computer and the process. So why it is there? It is to evaluate the goods produced or evaluate the products produced, whether the products coming out of the computer are of the same quality or not. So this is how the things will work in mm, what to say DDC. DDC is the direct digital control. So advantages of DDC are as follows. First one is cost, cheaper than analog control, as a single digital computer can control large number of loops. Performance, digital control offers simpler implementation of a wide range of control algorithms. So you can change algorithms, you can use the same processor or the computer, improve control accuracy and reduce drift. So drift means better is to, if you want to understand the drift, just go through with your analog devices. Analog devices are more prone to drift. For example, the pressure gauge, what is showing the pressure may vary with tolerance, plus or minus 5%. Whereas the digital gauge will show you the correct number, 32 psi for the pressure, 32 psi is the pressure for the tires. So if you set it digitally, the pressure set is exactly 32 psi. Whereas if you go with analog gauge, the problem would be there. You cannot fill the exact gauge of air inside the tube or tire with the help of analog devices. Analog devices are more prone to drift. They drift. The measurement is not accurate. Whereas the performance or the drift is very high or accurate in uh, digital devices. Digital controller, there is no chance of drift. The device, once it is calibrated, it will work fine for many number of years. Safety, yeah, safety is the main issue why we are going for computer control. Is that one common and the primary goal is safety. Safety, modern digital hardware is highly reliable and long mean time between failures and hence can improve the safety of systems. So safety is one such issue which is a concern in all the fields of life, or all the aspects of life. Well, like we are following the guidelines, like staying in home and not stepping out. Why? Because safety. If something happens to you, we cannot be replaced, right? Something happens to us, we cannot be replaced. We all are unique. We all are unique. That's the main idea. So safety is one such phenomenon. If the computer fails, no problem. You can replace the computer. Whereas if something happens to you, uh, then you cannot be replaced. That is the main issue. Why we are going for machinery or the computer controls. Computer controls. These are the advantages of DDC. So while discussing in earlier classes, we had come across this PID. So PID stands for proportional integral derivative. Proportional integral derivative. So this proportional integral derivative has to be applied for all the control applications. So proportional integral derivative PID control system. A small video is there. Just you just go through this small video so that you will be understanding what is PID. Wait 1 second. I'll just share the video. Okay.
Welcome back, and thank you for checking out this latest video brought to you by RealPars. Today, you will learn about PIDs, specifically what they are and when do we use them with automation and PLCs. Before we get into today's video, if you love our videos, be sure to click the like button below and make sure to click subscribe and the bell to receive notifications of new RealPars videos. This way, you never miss another one. So what is a PID controller? It is an acronym that stands for Proportional Integral Derivative. If you need to keep something constant, like a temperature for example, then this is the way to do it. Essentially, it uses a control loop feedback to ensure the output wanted is what you will get. Simply, you put a setting in the controller and it will keep the output constant based on feedback from some input, typically some kind of sensor. Something you probably encounter every day that is essentially PID control is your cruise control in your vehicle. First, you get to the speed that you want to be going. Then you set your cruise control. The cruise control sends output signals to your throttle to regulate the speed. A speed sensor provides your control loop feedback to tell the cruise if the car should speed up or slow down, or how much more or less throttle to provide. A common standalone type that we use in manufacturing and industry is a temperature controller PID. These controllers are pretty simple to use and set up. Plus, they do a great job at controlling temperatures of a variety of equipment. Let's take a look at how they work. For our example, we will look at a PID controller that controls the temperature of heat tracing on process piping. First, we need to enter a set point, 200 degrees Fahrenheit for our example. Now, the controller will give a signal to the output to start heating up the heat tracing. The control loop feedback is in the form of a thermocouple to read the temperature. For our example, the PID controller can work as an on-off control for the heat tracing. Along with the set point of 200 degrees, we will set the controller at a couple of degrees above and below 200 as well. When the thermocouple reads 202 degrees, it will turn the heat tracing off. When it reads 198, it will turn it back on. This is the simplest form of PID control. We also have the option of setting up a PID controller with a PLC. Instead of the standalone unit, we can use the input and output cards already on our PLC. The process variable, or control loop feedback, would be wired to our input card and programmed into the PID. Our output being controlled is wired to our output card. The PID and the PLC can do all of the math and make the decisions based on the variables and set points. No matter which way you decide to set it up, a PID is an excellent choice for an automated process. Let's look back at today's information. A PID controller is a proportional integral derivative controller. It can keep an automated process, like temperature, pressure, or flow, constant for you automatically. PIDs use a control loop feedback or process variable to monitor where the output should be. These usually come in the form of sensors and meters. PIDs come in many different forms, including standalone units and PLC programming. We can use our input and output cards along with programming software to set up a PID. I hope this video really helped you get a grasp of how to use a PID. They are a very handy tool to use. Don't forget to click the like button and subscribe so you never miss another Real Pars video. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.
%85 of people working in a job, they don't like their job, as per the Gallup survey. They want to start their business, they want to make money, but they don't know how. And guess what? I was one of those people as well. 3 years ago, when I was in a job making...
Okay, guys. We just got the glimpse of
PID.
okay. We just discussed about the PID, right? So now let us look in detail. That is, that was applied for an temperature control application. So PID was applied for a temperature control application. So there, just observe in that example, the temperature was set to 200 degrees Celsius. So you need to maintain the temperature of 200 degree Fahrenheit. But the set points were like that. It was set to 202 and 198. So the temperature varies, then only the heating on off was done on off. So it is applied for every major control system. So if you want to design any control system, then this PID will be applied. This PID will be applied first. So what is that PID? That we came across one example in your previous video. So now let us deal with this in detail. For wide range of industrial application, overall performance can be improved by using either PI or PID control systems. For majority of systems, PI control is sufficient. Proportional integral systems are sufficient. Whereas we can apply PID also. The ratio between control signal and the error signal can be adjusted using proportionality constant Kp. So here this Kp in our example was 200 degrees Celsius. The ratio was between 198 and 202. Using this Kp or choosing this Kp will have a significant difficulty. What is that? A high value of Kp will give a small steady state error and fast response, but response is oscillatory. So you can see that the on and off was done in an oscillatory way, which is not acceptable in many applications. A low value of Kp gives a slow response. If I keep the temperature below for 170 degrees below temperature, the system may require the on time of system will go high, which will be resulting in a large steady state error. That is why this Kp value has a importance in PID. So PID general format is like this: M of t is equal to overall control M of t is equal to Kp Kp is the proportionality constant or not the proportionality constant. It is the overall control gain. So always I find these answers in the scripts like Kp is the proportionality constant proportional. No, it is not proportionality constant in PID. It is changing because so we have written from +7, that is 7th standard to till now. Kp means proportionality constant. Kp means proportionality constant. OD now we'll write the same Kp as the proportionality constant. I've seen many thousands of students, thousands of students writing the same Kp as proportionality constant. So it is not proportionality constant here. It is overall controller gain. So Kp is overall controller gain. Then, so you have the Et. What is Et? Et is the error. Error in the previous example was 2 degrees plus 2 degrees minus 2 degrees was the error. The correction was required was 200. The temperature goes beyond 202. The system was off. When it is below 198, the system was on. So error is the same, the value r of t minus c of t. R of t is the measured variable. Sorry, c of t is the measured variable. R of t is the reference value or set. So set point was 200 degrees in your example. Set point was 200 degrees in your example. C of t is the measured variable. If it is 198 on the system, if it is 202 off the system, that is what is the A of t. That is what is E of t. E of t is the error. E of t is the error. C of t is the measured variable. R of t is the reference value. Similarly, Kp multiplied by E of t plus 1 over Ti. Ti is the integral action term. So this is the integral term 0 to t, limit 0 to t, E of t into dt. It is the integral term. Proportional integral derivative. So this is the integral term. This is the derivative term. So in the looking at the general form, you can easily make out that there are two terms. One is the integral term and the derivative term. Td d E of t divided by dt. Where Ti is the integral action term, Td is the derivative action time. So PID control is very important for your exam point of view. And a question will be asked in the exam. Explain PID. Then you have to write with write the answer like this. So this is what is the required explanation. So general form has a lot of importance. It is applied for many of the majority of the industrial applications require this PID. So this RTS is very near to your control systems also. The subject control system what you studied in your fourth semester, it is very much equivalent to your the application of control system. The concepts what we have studied in a control system supported by this subject. Okay, so there is a branch called as industrial electronics. There, the electronics will be the machineries will be controlled by the electronics. There, we can find this application PID control. So with this, I'll stop here. If you have any doubts, you can raise your doubts. Unmute yourself and raise your doubts or ask your doubts. Very important concept for your exam point of view. Explain PID control for 8 marks, 6 to 8 marks. If you have any doubt, you can ask me. Otherwise, mark your attendance and you can leave the class. Okay, no doubts. You can mark your attendance and you can leave the class. Thank you very much. 657 677.